Hello and happy new year and welcome to my video about puzzle games. So in the past I made a video about a game I was working on, and given that I haven't uploaded a new video in quite a long time, I think like 4 months or something, you might have guessed that I stopped working on it. However, I wanted to talk about puzzle games today and also why I stopped doing that game. So um, there's one category of puzzle games, and I call them here grid-based puzzle games. Some people call them Sokoban games because there once was a game called Sokoban, and this was kind of the first one in that direction. And so yeah, some people call them Sokoban games. So in grid-based puzzle games, which are probably the games I like the most in the puzzle game genre, there are kind of three different complexities of games. Not only does that mean the complexity of the game itself, but also of the program behind the game. So obviously, the more complex the game is, the more complex the program has to be. At least normally that's the case. So there are three kinds, and as you probably have seen already, here is the game. Whoa, the brush. Um, Here is the game that was kind of the um, blueprint for the game I wanted to do, and as you see, somehow I changed this to, oh my god. I changed this to red color. This was kind of the game I use as a blueprint for my game, and as you see, this is in the most difficult and most complex category. And I have realized that at some point, and therefore stopped working on it. So that the thing was, it was just too complex, both gameplay and programming wise, that I said, well, I should focus on one of those two things, so either programming or game design. And yeah, therefore I'm making something new in the new year, and this is both easier in terms of game design and programming. And I just decided that it's really more important to me at the moment to get better at programming and not at game design. So I rather want to concentrate on programming for the moment or for the new year, and game design shall probably come as a later part. And since this is so complex with game design and programming, this was just too complex for now. Right. So that's why I stopped my game. So let's talk about the grid-based puzzle games more. So I don't know if you know the original Sokoban game. It's basically is a game where you, um, I don't know, a person. I think it's like a warehouse manager, and Sokoban is like Japanese and means warehouse manager or something like that. And you push around boxes. That's basically the game. So it's a turn-based game, and it's a simple object. So it's either a player or a box or a crate probably, and you push them around. So every time you do a move, like that's turn based. So you can do a move, but other than that, nothing happens. Great. Then um, there's the second category. We will look at the game in a few minutes, seconds. I don't know. There's a second category which is a bit more complex. It's still turn based, but the objects in the game, they do have a state as well. So examples for that are A Monster's Expedition, which is a game of 2020. Maybe you have seen that, but you probably know Steven's Sausage Roll, which is quite a famous um, puzzle game and quite difficult as well. I mean, they're both not difficult. Um, so in those kinds of games, we will look at that at those later on as well, or at least at the first one. Um, It's also turn-based, so every time you move, the world moves, but other than that, nothing happens. And the objects, however, how the objects, they have a bit of a state. So here it says object with state. So for example, in Steven's Sausage Roll, if you know that, um, you have those double-sided sausages. I don't know, they are kind of, so those sausages. I'm too stupid for that word. They kind of look like that. So they first of all, they just like the character itself as well, these sausages are bigger than one tile. So there are two tiles, which already the original Pokemon game that did not have that. Here, like all the crates were one tile, and the player was also one tile. Here, the sausages are two tiles, and they have like um, internally they have two sides, so you can turn the sausages, and each of the four outsides. Wait, I could mark them like with green. I don't know. So like this side of the sausage, and this one, and this one, and this one. So when looking from the side in the game, you would actually look on it from top view. But each of those four sides, they have to be put on a barbecue, or on a, I don't know, on a, let's call it barbecue. I would call it a barbecue. Um, and you have to heat all those four sides of a sausage exactly once. And if you heat them more than once, they will burn. So this sausage kind of has a state. So because it has to remember for those fields um, whether they have been heated already, or if they have been overheated or overcooked. I don't know how they call it. I just played it a few days ago, but I don't know how they call it. Overcooked, overheated, black, burned, probably burned. I don't know. Um, yeah, but the game has to remember that. So the sausages kind of have a state. And then there's the more complex one, which was, for example, the Tokitori 2 game I have talked about in the last video, or the new unannounced game of Jonathan Blow. I don't know if you know him. Probably you do know. Um, yeah, he has kind of a game he's working on, and he has a lot of videos about them. He even has one 5-hour video why this kind of game is so complex to make, and I will probably link that in the description. And those games, they don't have a turn-based back end, so they kind of work continuous. So even if you do nothing, the world moves. And yeah, so if you don't do anything, there still are animals or whatever that walk around. They might even have different velocities with which they walk around, and this gets really complex. And therefore, obviously, the objects also have a state, so they at least have a walking direction, and they maybe have a velocity, and they have whatever other state they might have. So for the first type of game, there is a tool called Puzzlescript, which is kind of a mixture between a programming language and a game engine. And it's actually by Stephen Lavelle. So, and Stephen Lavelle is this Stephen in Stephen's software. So this guy made a programming language, or whatever, or engine, however you want to call it, for these type 1 kind of games, I call them. And it's called Puzzlescript. And we will look at that right now. So you can go to puzzlescript.net/editor.html, and this is it. So here you see a game. This is kind of like Sokoban. So what you have to do, you can walk around. You are this person, and those outside things, they are obviously walls, and this green one, this is just grass. This is just for nice looks, and those orange ones, or I don't know, brown, is that's supposedly it's orange. Those orange ones, those are crates, and you can push them around. So you can push them around, but only one at a time. So I can't push those two together. So, and those black ones, although it says they would be dark blue, I think they are black. Those are kind of, I don't know, pressure plates or something, and you have to put those boxes onto them. So this one is already on one pressure plate, and you have to put the other box to the other pressure plate. Then you have finished the level, and I have absolutely no idea how to do that. I think I have to push this one up. I played it yesterday already, and it took me quite a while. So this is the solution, and if you're done it, you come to the next level. And how this system works is very easy. So like I said, you can just go there and then here's load example, and I think basic is what we see at the moment. And there are quite some more difficult games in there. And the most difficult one is obviously blank project, because that means you should do something on your own. So how this system works, it's really easy. You can define the object at the beginning. So you basically say, how is the object called? Then you can put in some numbers, and then you kind of define the pixels on such a tile. So this is the background pixel, so the grass pixel. And then just say, okay, there's light green in there, there's green in there, and then you can you can just create it. So 0 means the first color and 1 means the second color, and then you have this one, and if you compare it, it looks exactly like one of those grass tiles. And you make it with all the objects. So here's the target, which I think is a brush blade, then the wall, the player, the crates themselves. Then the next step is making a legend. Basically, you just say each thing you want to have that can be on one position in the game, you represent by one letter, and then later on you can make levels. So at the very bottom you say levels, and then you can just use one letter per tile and create those levels. And they look they use this thing here as a lookup table. So a dot means basically empty, and a hashtag is a wall, and a capital P is a player. And we see that. So this is level 2, and here's the capital P. That's where the player is, and the hashtags are the walls, and the periods or dots, however you want to call them, those are the grass. And I don't know, the O is the pressure plate, and here is an asterisk, that's a crate, and the @ sign is a crate and a pressure plate. So that's the game. Right, you also have to define the win condition, which is very easy. So all the targets, so those are the pressure plates, they have to be on crates, or well, actually it's the other way around, but that still works. So all the crates have to be on pressure plates. And you can also say which of the objects collide with each other. So the player collides with walls and with crates. So we can't walk through walls, or we can't walk through crates. But other than that, the background doesn't collide with anything, and those pressure plates, they don't collide with anything either. And here is the actual rule of the game, and this is just one line, and that's why the system is so awesome. So what this means is it checks the game for a player standing next to a crate. So this means player, and then next to it is a crate. And this arrow at the beginning means the player, so it's standing inside of the player. So that means the player is walking towards the crate. So this right arrow just means that this object moves towards this object. So the player moves towards an adjacent crate. And what happens, like this is what happens afterwards. The player is still moving, and the crate now is moving as well. That's how the whole system works. So we can do that here. So now when I move to the left, that means I move towards the crate, and following, I will still move to the left, and the crate will now move to the left as well. So that's the game. We could now add a rule for what happens if I push 2 crates. So at the moment, wait, oh yeah, the whole system also has reset and undo buttons. So that's also done for you already. So if I now move downwards, nothing happens, because I can only move 1 crate at a time. And we can now change the rules. We can now say, if a crate is moving towards an adjacent crate, then we have a crate that is still moving, and the other one is now moving as well. And we can rebuild the whole level. Right, and now if I move downwards, they both move downwards. And we can do even stupider stuff. So we can say, if we move 2 crates, then the first one will turn into a player. I think that should work. Right, now I have two players. This is dumb, and I can control both of them? What, this is actually funny. So, and now if I move down as well, yeah, now I another one turned to a player. Okay, this is really dumb. Yeah, but you can do that, and this is basically how the whole system works. What we also can do is we can, for example, say if we move away from a crate, we are still moving away from the crate, but the crate will move also in that direction. So this way we can pull a crate instead of pushing it. So now if I move upward, I can just pull it. I'm not sure if I can, wait, probably I move to the left here, and I can then move this one downwards, and this one to the side. So we change the pushing to the pulling, and we can do all sorts of, a lot of things with that. We can also say, for example, I know I'm not sure how they're called, up, down. So we have the original rule with pushing, but we say it only works left, up, and down. So only if you move left, up, or down, we can push stuff. And when we move right, we can only pull stuff. So if I'm rebuild that level, oh, wait, no. I can push stuff to the left, and I cannot pull it. Theoretically, that should work. Wait, if I move away from a... Okay, for some reason, right means standing on the left. Okay, the system is complex. I have really no idea why. Huh? Oh yeah, right. I'm stupid. It doesn't care about how I move. It cares about how the player and the crate is oriented. So it means the player and the crate is on the right side of the player. That's how the system works. Yeah, right. That doesn't matter at the moment. But this is in general how the whole system works, and we can look at more advanced games. Maybe they look a bit yeah, I want to use my unsafe project. Maybe they look a bit more advanced, so you have several stuff. So you can also say those rules only work horizontal or only work vertical. You can even say some stuff is late. So that means this rule works late, is executed at the end. And you can even say you can cancel something. So if something happened which should make the whole move not work, you can cancel it, and then it just deletes everything it has done this move. And this is the whole system. And however, I want to... Oh, look, this. I have... Oh, okay. So you see those. I have those. I can walk through the sand, and it saves where I walked, and I can't cross it. It looks really stupid because you don't really see it. Oh no. Probably I messed up. Oh no, this one is missing. Oh, this one maybe as well. Okay, it looks really stupid. I mean, it's really hard to read. Yeah, but the whole game or the whole system only really works well with simple objects. Just like I said here, it's turn-based. I saw games that are not turn-based, so they support something like that as well, but it's really difficult. And the objects should all be very simple. So most of the times, the games in this in Puzzlescript most of the times the objects are just one tile big. There are games with bigger tiles, but it's really complex to program because you I think I tried something like that once. But I didn't save it. Oh no. It's really difficult. So what you have to do is basically you have, or at least what I try to do, you you have to create an object, and if it's 2 tiles wide, you kind of have to specifically say this is the left side of the object or this is the right side of the object, and this gets really annoying very quickly. And so what I did, I wanted to partially recreate the game A Monster's Expedition. And in that game, you have trees, and you can. So the trees are the crates of the older game, but they have the additional thing that they can roll in one direction. So you can lift up logs, but you can also, if they lie on the floor, you can roll them. So they kind of have a state in which direction they roll. And I wanted to recreate that, and I started doing that in Puzzlescript, and it was really annoying. And then I made something on my own, and well, I haven't finished yet, but that was just kind of a prototype for how I would do such a game. And this is it. So first of all, let's look into the game. Well, look into my fake version of the game, which is also missing a lot of things of the actual game. And I've done that in Unity because I was stupid probably at that time. I don't know. So Unity gets more and more stupid over time, I think. So at the moment, I have 2 windows of Unity open. The second window is just empty, but if I close it, it will close my actual window as well. And this happens now every time I use Unity, and I have no idea why that is. Um, so okay, this is the very simple version of A Monster's Expedition, and you are obviously the red dot. Oh no, spoilers. You are the red dot. Well, in the actual game, you are obviously a monster because it's called A Monster's Expedition. And you have those trees standing around here. And what you can do is you can, well, yeah, you can, I don't know, kill the trees. You can throw them down, and then they turn into logs. And you can even put the log up again, but now it's not a tree anymore. It's now a log, just standing on a tree stump. And you can actually move on top of that tree, on top of that log, and you can roll it around. And now if I would lift that up, so if I move upwards, nothing happens. But another thing that is possible in the game is actually you can create rafts, and you theoretically can put them into water, and then you can run around. You can what did I want to say? You can use the raft and put them into water, and then you can push yourself away through the water, so you can kind of ride on the raft in the water. I mean, that's what a raft is for. That's probably a huge spoiler because that's like the moment in the game where you actually start the game. So there's like a second intro screen where you discover that you can use a raft to move around. So, however, I programmed that in Unity with a different system, and I wanted to show how that works. So yeah, another thing is that's what I said before. So if a log lies on the floor and you push it sideways, it will roll until it hits something. So this time, those gray ones, those with the gradient, those are kind of high, I don't know, like mountains. Whereas the other gray ones, they are rather, I don't know, kind of a flat rock, so you can actually move on top of them. So yeah, I just pushed the log on top of that. I can actually, when moving from a tree stump, I can actually move on top of those little rocks. Right. So okay, how does this work? So first of all, oh no, I should keep it running probably. Oh no. So that's obviously also an editor, so I can, I don't know, put stuff down here. So that's not important. So first of all, what I did not want to do is the Puzzlescript solution would be to have the Puzzlescript implementation would be to have different objects for a tree, like this kind of tree, so a still functioning tree, or this kind of log just standing on top of a stump, and it would have a new object for tree for log lying vertically, or a new object uh, for a tree lying horizontally, and a new object for having a raft. And this is not what I wanted to have. I just wanted to have tree and kind of a state. So what state is the tree in? Is it standing? Is it lying horizontal? Is it lying vertically? Is it a raft? But all of them, they're just a tree. And also the trees, they have to have a position. They do have a movement direction. So if I push it downwards, I can just say this tree is now moving downwards. Whereas in the Puzzlescript thing I started, I would actually I had two choices. So one choice was I have three different objects. No, I have actually five different objects. So I have a horizontal lying log, which does nothing. I have a horizontal lying log that moves downwards. I have a horizontal lying log that moves upwards. Or I have even one that moves left or right. So when I try to lift them up again. And the other solution would have been I have a horizontal lying log, and then I have another object on the same position that said this log on this position is currently moving to the left or to the right or upwards or downwards. This was totally stupid. And so here in this case, I actually just have, wait, I can even show you. I can show you, but it looks really dumb because it's object-oriented programming stuff, and that's always dumb. And so a tree object that has some special tree data. Tree data basically just means that's actually a struct, but the struct only has one enum, and that says what type of tree am I? So am I horizontal, vertical, raft, tree, standing? That's that. Other than that, all the objects, they pretty much share what they have. They have a direction in which they move. This, by the way, gets reset after every turn. And they have a position. They have a height. That's what I thought is probably useful in such a game, because you often have different height values. And they also have a done field. So basically, I can say done, and then this object will not be updated anymore in this turn. So, but that's basically it. I have it somewhere in the game, somewhere in the project. I have a tree object, and it just holds all the position, state, height, done, movement direction. That's basically it. And now what I do in the game. So now we will have to see if Unity lets me put a breakpoint in my program, because Unity often ignores breakpoints for no reason. Yeah, I think it's here. So what happens if I want to make a turn, or if I want to make a move? I press now downwards. Oh no, I didn't stop the. No, wait. I didn't start the debugger. Haha. Now I move downwards. Nope. Hello. Unity is such a good engine. Okay, now the debugger is actually running, and so it caught my button press. So this is how the game basically does its update. So first of all, it checks if the player hasn't been updated, if the player hasn't been moved already. I do. I really don't know why Visual Studio Code and Unity don't work together that good anymore. People might say I should just change the editor, but I think I just change the engine. So okay, if the player is not done yet, we just do some very easy things. So we just check what position is the player on and where does he want to move. So, and then we have to calculate an index in an array which saves all the stuff. Yeah, ignore that. So we now find out what is the tile the player is standing on at the moment, and what is the tile he wants to go. I just say he for the player, I don't know. Wait. So the player is standing on land. I called that, maybe you should call it grass, maybe that's yeah, better, I don't know. And he will move to this place here, and there, underneath the tree there's a tree stump. So the tile here is land, the tile here is stump. There. And then I check what is the highest tree on the goal position. So there can be several trees actually on one position. I do not even know if the game does that, but in my implementation, which as I said isn't actually finished, theoretically I can have up to 3 trees on one tile. So I can theoretically have a raft in the water, and I can put down a raft on top of that one, and I could theoretically put down a tree onto the raft on the other raft which is in the water. And so you could theoretically have 3 trees on top of each other. Now I have to check which one is the highest one, and then I actually also check which is the highest tree I am standing on. So I could be on a tree as well, or I could also be on a tree that is standing on a raft. So I could also be on several trees, but I just get the highest one. And then I translate that. So I told you that there are horizontal logs and there are also vertical logs, but it's very stupid. So I rather translate that to have, if they are lying, so if there's a log lying on the ground, instead of saying it's vertical or it's horizontal, I rather wanted to say, is it parallel to how I move, or is it orthogonal to how I move? Because this is actually important for the rules. And whereas whether it's vertical or horizontal doesn't say anything as long as I don't know in what direction I walk. So I translate them here. All the other states they stay the same. So if it's a tree, it stays a tree. If it's standing, it is still standing. If it's a raft, it's still a raft. But the horizontal and vertical, those are translated to parallel or orthogonal. Now, what I do have now is I do have a 6-dimensional array with the following stuff. So I have a 6-dimensional array, and the 6 dimensions are the tile I'm standing on, so which is land, the height of the player, the state of the tree I am standing on, which at the moment is none because there is no tree beneath the player, the goal tile, the height of the tree on the goal tile, and the tree type on the goal tile. So those are the 6 dimensions, and this then returns me a list of function pointers, and I have to do those functions, and that's the whole system. And then later on, so down here, I do the same thing, but instead of players and trees, I do it with trees and trees. So if a tree now has a direction which it shall move, it will do the same thing as a player does, and then it has another 6-dimensional array which checks for the tile the tree is standing on and the height of that tree and so on, and it checks the goal tile as well, the goal tile and the goal tree and the height of the goal tree. So, and we can see that here, but let's probably disable the debugger. We don't need it anymore. Wait, let's go back. So now I push down and we can see here, so this is the 6-dimensional array. So player tile, player height, tree under player, goal tile, goal height, goal tree. And so the last move I did, I was standing on land. There was no tree beneath me. I moved to a stump. There was a tree on there, and it was a tree, so an actual tree, not a standing log, and also not a lying thing, and also not a raft. And what I have to do now is I have to push the tree. And push tree means actually two functions. So first of all, I try to push the tree, and the second one is I set myself to done. So if I want to push a tree, I am done afterwards. So my turn is finished, basically. And this is how the whole system works. And we can make something more complex, maybe. So if we do this one, and now if I think I already showed you that if I now push the tree down, we will create a raft. So I was standing on the land. So basically the same thing as last time happened. I was standing on the land with no tree underneath me. I walked towards a stump. There was a tree there, and it was an actual tree, and I pushed it. And what then happens internally, the tree got a movement direction assigned. So now the tree said, okay, I have to move downwards. And what was that? So yeah, now here's the second 6-dimensional array for tree interactions. So this one is the tree, and the one we had before was the player tree. And this is the tree interaction. So, and now we see the tree was standing on a stump. It had the height high, because stuff that stands on a stump is high. The high thing is a bit stupid. I want to change that in the future, maybe. It was a standing tree. Actually, it was a tree, but in the game I already changed it to standing. Ignore that. The goal tile was land, and there already was a log. It was on height normal, which means basically it's lying on grass, and it was lying parallel to how the tree was moving. And that means I have to create a raft. And this is super simple in theory, because it just says, okay, those are the things we had, and this will happen. And now we can look up create raft. What is create raft? Create raft actually calls another function, which is called create raft. So most of the times only one action happens. Sometimes several happen. And most of the times, if several happen, the second one is just a set done. Right. So I said we have a 6-dimensional array. This also means we have a whole bunch of values. So we have 14,400 different combinations for the tree interactions, and we also have 14,400 interactions between player and tree interactions. So I have set almost all of them already. So 13,587 of them are already set. This sounds like a stupidly high amount of work to do, but it's actually very easy because you can set several of them at the same time. So, oh yeah, I haven't probably talked about that correctly. So, this is the first line, the one in gray, is the stuff we did. So the stuff that was there. So I was on land, no tree beneath me. I moved onto land. There was also no tree there, and therefore I walked. This is what I'm doing now. And now those layers beneath there, they just say if I would change one of the values, so if I actually started on a stump instead of land, well yeah, then I also would have walked. If I would have started on a flat stone, so flat stones are those ones, I also would have walked. But there are other things that just say, so for example, if I would not have moved to land but to water, so here, so if I now push down, this thing here will happen, and nothing happens. So this just says, if I would change one of the values, what would happen then? And there's a whole bunch of them. This is the red one, so this one, which is just not possible. So, and this is also why setting the values is really easy, because I can modify the whole 6-dimensional array at once. So for example, I can say the player tile is, I can say it's either not defined, it's specified, or it's all of them at the same time. So I can say player tile high stone. So the player is on this mountain here outside. this is never possible. No matter what I do, this is never possible. So I can just say, I can just choose all of them for everything else and just say this is not possible. And so I set the whole array to not possible. Right, I could also say, I don't know, high stone. What is also not possible? For example, I cannot be on land standing on water. Wait, does that make sense? Yeah, right. So the player height says, what is the height of the tree I'm standing on? I cannot stand on a tree in water if there is no water, right? So if I'm standing on a grassland, I cannot stand on a tree that's on water. So I can also say, this is not possible. And I already set a lot more values now. So therefore, this is actually a really easy system. And this whole system has, I think, 3 other benefits. So first of all, if you have created those different actions, you never have to recompile your game. So you can just walk around until something happens and you say, well, either this was good or this was not good, and you can just assign a value here. By the way, you can also assign those other ones, those connected ones. The second cool thing is you can send the whole thing to someone else and they can just change some of the values. So you can send it to someone else with the 6-dimensional array, or with, well, depending on your game, whatever dimensions you have, and they can just change values, and then you can actually diff them with your, so you can, wow, diff them, wow, that's nerdy. You can compare them with what you have done, and then you can just, you can talk about, hey, why did you want to do that thing? Because I wanted to do this thing in this case. This is also very nice, because if you would have code and you would send it to someone else, they either would have to change the code, or they, which you probably don't do, because either they're not no programmers, or they just don't want to work with your code, or your code is really ugly, or your code is exactly structured in a way that that works with directly these rules. But if you want to change one thing, you would have to rewrite a whole bunch of it. So at the beginning, I wanted to write that with just if and else cases and a lot of switch statements, and it was really ugly if you want to change something. And so that would be amazing. There's another thing, which is right. So I can, what I also can do, I have this dummy button here. It at the moment says dummy, so that no one knows what it does. So what it does, it just randomly plays the game until now it came to a position. So first of all, it said here an unimplemented rule has been executed, and therefore it aborted when I moved downwards. So when I moved downwards, the game reached a combination in the arrays, so where the rule was not implemented, and it just stopped there. So you can just smash this button, and it will always simulate the game until it comes to a position where it doesn't know what to do, and then you can just assign it. So okay, the game does not know what to do when moving downwards. So why is that the case? Okay, we have the tree, and so it says the tree interaction. Okay, so it's the game doesn't know what to do when a standing tree from land falls onto a tree lying there in water. And as I know what the game does there, it creates a raft. Now I can do the move, and I can see, oh yeah, this is actually the thing I wanted to do, and then I can continue. Okay, now continue simulating the game. And now we have a new state where we don't know what to do. However, oh yeah, it didn't reload it. So it's already, it's not already, it's again a combination with a tree combination. And now this time it's moving upwards, so it says it aborted when moving upwards. And this time it's a standing tree falling onto a lying tree, lying on a tree stump, and I have absolutely no idea what should happen then, and I can just say, I don't know, don't know. So what that does, so don't know is this extra category here. It just remembers that it's not implemented, but it will not stop on those. So because if I would press a dummy button now, I would end up at the same position, because it says, well, this thing is still not implemented, but don't know basically means, okay, ignore it for now, and we can continue. And yeah, so it's a really simple system in my opinion. And given that those types of puzzle games, wow, I think it messed up something. What? It aborted when moving upwards? No, when moving downwards. I'm really curious now. Oh no. Okay, the system doesn't work perfectly now because I can't. When simulating the game with this dummy button, the game does not uh, save the undo information, and so I can't actually undo the last move. So I guess somehow one of the logs moved downwards, but I think this thing here already is not possible normally. Oh, I know what happened. Okay, I don't care about that for the moment. I think the log moving downwards rolled over this one lying vertically, crashed again against this one, and then it should actually create a raft now. So, however, the system is really simple because for each actually possible combination of things, you can specifically say what shall happen. If you now think about, you make a game and I don't know, it takes a year to make. Checking those stupid 14,400 all by hand at the end is probably not too much of a hassle. I mean, you don't have to do them all in a row, and all the ones that are definitely not possible, I mean, you can ignore. But all the other ones, you just check once, and then you say, okay, this one is really correct, what I want to do, and then that's it. And then you have checked every case, and you can just, I don't know, you could modify it. So like this one has been manually checked, and I'm really sure that this is what shall happen. And then you have the game. And I realize now that I've talked way too long now, but that was just what I wanted to show. So I have done that in, I don't know, like August or September or something. But since it has become this huge Unity beast with generic programming and whatnot, and Unity is really annoying me, I never really have continued it. And since I promised to make a video in the old year, although I've already broken that promise because it's the new year already, I just wanted to make this video. And yeah, right. In the new year, I will actually work on something else at the beginning, and at least for the first half of the year. But I might use some of my time to port this thing to C, so to a better programming language. And then I want to do some more things. So what I also want to have is kind of a procedural level generation. So what the backend already actually does is it saves the moves it had to do. So what that means, if you press the dummy button, the game basically generates all the possibilities and the order of actions you did, and then you say, okay, you have this level and this is the order of actions you did to solve them. And you probably could generate levels with that. So you just generate a random level, then you simulate it, and then you get a list of this is the best move in there, or this is the amount of different moves you could actually do in this game. And by that you could probably um, yes, say which levels are good or which ones are bad, and you could also save which rules do I as a player have to know for this thing to work, and stuff like that. However, I think Unity is just too slow for that because you create a bunch of objects and you delete them and all the garbage collection. And I might port that to C and then do the actual procedural generation of levels. Maybe it's still stupid. I could think that you might be even able to port that to a graphics card and do that all that simulation and stuff in parallel. And I want to test that out, and for that I would have to move it to C anyway. And yeah, that's basically it. I mean, if you watched the whole of the video, yay, thank you. I think you're stupid. I hope you set the video to a higher speed. Um, if you didn't understand anything of it, just write in the comments with N. Yeah, I really don't know if I missed something. I don't think so. Oh yeah, I mean my I think I showed that, but I don't have to show that. My game also obviously supports a redo button. Oh yeah, I talked about that, and the reset button. And so the original plan was to actually make like a more generic tool, which I might even publish. But yeah, just the whole Unity stuff just annoyed me, and then I stopped working on it. I don't know. So you will hear updates on this, and in the following days there will probably be even more updates. So there's I will do one other video talking about another project, so the thing I did in the last month or so, and there will be a video talking about the year 2021 and what I will do in the year and what my plans are and all that stuff. So if you're interested in that, I don't know, probably not. And yeah, that's basically about it, I think. So as I said before, thank you for watching this whole thing if you did that, and until next time.